Okay, let's flip to the back. All right. So this back is finally going to start dealing with multiplication when x is on both sides of the problem. Multiplication is actually a really powerful operation. We haven't seen a lot of it in a little while, and you'll see why below. So before we start, I want you to do these two problems. Trust me, it's no trick. Just try them out real quick. Okay, so like you know, we have x over 4 here, so I want to multiply both sides by 4. This cancels out the fraction, and I find out that x equals 20. Okay, next one up. I want to make sure I get my 2 to the other side first, so I'm going to subtract 2 from both sides. And I find out that 1 over 3 x, which I want to make a note, 1 over 3x is the same thing as x over 3. Having a fraction next to your x and having your x on top of a fraction are the same thing. So when I'm writing 1 over 3x, I can treat it like it's x over 3. So I subtracted 2 from both sides, and I found that 1/3 x equals 2. Now that I've dug towards my x, I can finally get rid of the 1/3 by multiplying both sides by 3. X equals 6. Okay, now that I'm there, so what's going on? We're multiplying both sides of an equation, but why? Turns out we can multiply both sides of an equation by anything we want to, and it's going to have different effects based on what we do. So above we multiplied both sides by 4, but what's stopping me from multiplying both sides by 8, for example? We learned a couple notes ago that when you multiply a whole number by a fraction, you move that fraction, you multiply it by the top and divide it by the bottom. So I have 8x over 4 equals 8 times 5 is 40. Now 8 divided by 4 is going to be 2x, and then I bring down my 40. Ultimately, I'm going to divide both sides by 2, and we'll find out that again, x equals 20. Ultimately, we can multiply by whatever we want. I can do, let's say, 40 here on both sides, and let's say 1,000 here. Nothing can stop me from multiplying by whatever I want on both sides. The problem is, what's the point? Your ultimate goal is to get rid of the fraction. Now, multiplying by 4 is effective because it just cancels at the bottom. If I multiply by 8 or 40 or 1,000, you're going to end up with something connected to your x on the top. That's because multiplication is such a powerful operation. So, not only that, because it's such a powerful operation, you'll see it does something really interesting if we multiply before combining everything. This is exactly why we dig towards our x. So in the first example, I want to get rid of this 1/3. That means to get rid of it, I can multiply both sides by 3. Now instead of canceling everything out and then multiplying by 3, I'm going to multiply by 3 first. And you'll notice I drew these parentheses because when you're multiplying both sides of an equation, everything gets multiplied. Every single term gets multiplied. We're going to do distributive property to show this actually working out right. The point is, if you multiply too early, you're going to get a lot of big numbers really fast. So, I multiply 1/3 by 3 and 2 by 3. So, 1/3 x is going to just become x because the 3 and the 1/3 cancel out. 3 times 2 is going to be 6, and then 4 times 3 is going to be 12. So I distributed, got numbers, then I want to subtract 6 from both sides, 6 from both sides, and I find that x equals 6. That was the same answer we got above, right here. But we had to do all this distribution stuff before we got our answer. I'd like you to try this as well. You're probably going to want to multiply both sides by 4 to get rid of this fraction. But I want you to see what happens when you multiply before canceling everything out. Gets a little confusing, doesn't it? Alright, pause and try it out. Your final answer should be x equals 64. Okay, so moving on down, what does this tell us? Well, it actually gives us a good reason as to why we combine everything before multiplying and dividing. There's a reason why we do that. It's because if we distribute everything, we're going to get really stressed out and have a lot of different terms to deal with. So like let's say I multiply both sides by 4 here and here. I end up with x plus 16 minus 8 equals 80 plus, or not 80, I'm sorry. Equals 32 plus 40. I have to distribute x into everything in the equation. It takes a lot of time, energy, and a lot of big numbers. Instead, if I just combine everything first, so I combine 4 minus 2 is going to be 1 over 4 x equals 2 equals, 1/4 x plus 2, 4 minus 2 is 2, equals 18. That's going to be much easier for me to deal with. And playing with my combining rules above, I don't have to deal with that crazy multiplication like I did on the left right there. So I want to subtract 2 from both sides. I have 1/4 x equals 16. And this is much cleaner, much more manageable. X equals 64. So that's the point. We multiply last because if we do it first before we combine everything, we have to multiply a lot of stuff and it gives us a lot of big numbers. There are situations though where that's really helpful. Mostly it has to do with fractions. Remember, when you multiply a fraction by the number in its base, you get rid of the base. The fraction goes away. So by multiplying both sides of an equation by whatever number you might choose, you don't have to deal with fractions anymore. I'll show you what I mean. So in my first question, I have 1/4 x plus 8 equals negative 3 over 4ths. If I multiply both sides by 4, I won't have to deal with any ugly fractions like 1/4 or negative 3/4. I'm just going to multiply 4 times 1 over 4 gives me x. 4 times 8 is going to be 32 equals, here I'm just going to have negative 3 because the 4's cancel out. I subtract 32 from both sides. And I end up with x equals negative 35. If I hadn't multiplied both sides by 4, even though I multiplied all my numbers, I would have had to deal with those fractions, and I don't really want to do that. The biggest tool for multiplication is to deal with fractions. Okay, I have another example here. I have 2/5 and 4/10. Well, I want to get rid of both fractions in one operation. So I want to multiply by their least common multiple, the lowest number that they have in common. 5 goes into 10, so if I multiply both sides by 10, I end up with 2 times 10 over 5 times x. I end up with 20 here, minus 40 equals, cancel out the 10s, 4. What I can do with this becomes 4x minus 40 equals 10 equals 4. I add 40 to both sides. 4x equals 44. Then I can divide by 4s, get x equals 11. I got rid of both fractions by multiplying by their least common multiple, by multiplying by whatever number will cancel out both of them. That was 10. I canceled out my 10s here. I multiplied the top by 10, divided by the bottom, and I got this clean equation without any fractions in it. Once I got there, it's just like any other problem. I dig towards the x, and I figure out what x is equal to, which was 11. I want you to do a similar process. I want you to figure out what you multiply both fractions by to get rid of the fractions. Once you're there, you should be able to solve the problem. Pause and see if you can give it your best shot. I'll explain it in a moment. Okay, so I want to multiply both sides by 6 here. By doing that, I'll be able to cancel out the 3 and the 6. So 6's cancel out. My right side is going to have 4. I'm going to have 6 times 1 is 6 over 3, x plus 2, plus 12, sorry. Because I distribute to my 2, I end up with plus 12. 6 over 3 is going to be 2x plus 12 equals 4. Now I can subtract 12 from both sides. Minus 12, 2x equals negative 8. Divide by 2, divide by 2. X equals negative 4. Again, same process. Multiply both sides by a number. Eliminate my fractions. I end up with an easy, usual two-step equation. Then I solve for x. This is tricky stuff. Here's your ultimate takeaway. When you multiply both sides of an equation by some number, everything gets multiplied. This is dangerous. It's why we multiply last after we move all of our terms around and combine. However, in situations where there are stuff like fractions, there's no easy way to combine everything. In those situations, it's just easiest to multiply and then to figure out your answer once everything's been multiplied. Okay, you have a checking understanding at the bottom. You may need extra writing paper to work out your answers here, but that's okay. I can give you that paper. It's crucial that you understand this process, so if you have any questions, by all means, please let me know. I'm more than happy to help you. As always, thank you very much, and I look forward to working with you in the next one.